In this lesson, we're going to be talking about one-way ANOVA. It's a slightly more sophisticated design than what we talked about for a between subjects t-test. If you remember, a between subjects t-test is limited to testing differences between the means of only two groups. If in your study that you're proposing you have more than three groups and you want to look for differences among those three groups, you would use a one-way ANOVA. The one-way ANOVA is a little more sophisticated in that in calculating the F value or the F ratio, and if you remember we had the T value with the t-test, but the F ratio here is an analysis taking into account between group variability and within group variability. So if you have three groups and you're interested in seeing if those three groups are different in some way, the F ratio takes into account within group variability and also between group variability. And it does it for each group with every other group. By doing this, within the formula, it controls for an inflated p-value. That is, if you remember, for each test, we say that the test is statistically significant if the p-value, or alpha, is 0.05 or below. However, if you are doing a one-way ANOVA with three groups, you're actually going to have more than one test if you, say, ran it with a t-test. You would have Group A and Group B, Group A and Group C, and Group B and Group C. You will have actually run three t-tests to do the same thing a one-way ANOVA can in analyzing the groups. However, in running three different t-tests, you are inflating the p-value. Each time you run it, it is at 0.05, but then it's another test at 0.05, another test at 0.05, another test at 0.05. At a certain point, you're more likely to make errors to find something that isn't actually significant just from running a whole load of tests, or what they call sort of a fishing expedition. So the one-way ANOVA built into the formula controls for this inflation of the p-value and corrects for it. However, the F-test does not tell you which specific groups are different from which other groups. It will, in the printout, tell you whether the test itself was significant, whether significant differences exist. However, you need to run a multiple comparison test, often something such as a Tukey or a Sheffe test that will tell you which group is specifically different from which other group, right? Because you could have Group A different from Group B, but Group A not different from Group C, and Group B and Group C not different from each other. So there's a whole host of ways that the groups can differ from each other, and the post hoc test will allow you to pinpoint that. Again, remember, the one-way ANOVA is the best and most appropriate test if you have a dependent variable that is continuous, and you have three or more groups that you're interested in seeing do the means of those groups differ on that dependent variable.